Step 4 of the upload process deals with compartments and communities. A compartment is a physical container within a vessel that we can measure microbial growth in. In many cases, a compartment will simply be the vessel. For example, a plate or a bottle with medium. However, in some cases, we may have a different scenario. For example, in this study, we have bottles that have Wilkins-Sjögren anaerob broth, and they also have mucin beads. These two are considered separate compartments because they are within the same biological system, within the same vessel. However, they can be measured separately. We can measure strains of Bacteroides, for example, in the WC compartment or in the mucin compartment. You can see that in both of these cases, the compartment is shown as a subscript. The vessel itself, the biological replicate, is called average Bt mucin or Bt mucin 1 or Bt mucin 2. But there are containers. We can measure metabolite measurements in the WC compartment, so we have that here, but we don't have mucin measurements for metabolites. We have mucin measurements for strains. Let's start the process by adding a compartment. I'm going to click on the Add Compartment button, and there's a lot of fields here, but all of them are optional and depend on your experimental setup. The name is just a label. When I showed you the Bt mucin experiments, you saw that it shows up as a subscript, but this only happens if there's more than one compartment per biological replicate. In many cases, the name will not be seen in the actual experimental data, only on the details of the study. So in many cases, you can use a placeholder name and maybe just a number that increments for every new compartment that you use. For the rest of the fields, ideally, we would describe the name of the medium, for example, Wilkins-Sjögren's anaerob broth. Ideally, we would also link to a description of the medium. Our recommendation is to use MediaDive here. MediaDive is a dedicated application with a list of lots of different kinds of media, a list of ingredients and solutions, and you can use their medium builder tool to define your own media. This is not mandatory. You can just link to, let's say, a PDF or a paper that describes your medium composition. But if you put a MediaDive link here, eventually we may be able to use their API to get the information into our own systems. But for now, we believe that it's best that it sits in a dedicated place. As for the rest of the values, I would recommend that you fill in as much as you know. In this case, I'm going to place 0% oxygen, 10% on both CO2 and H2, and 80% nitrogen for this composition, simply to have some data here. I'm going to post initial pH of 6.7. It could be the case that, let's say, in a chemostat experiment, you have a feed that maintains a constant pH. But in which case this would not be initial pH, this would just be a constant pH, same for temperature. But again, the labels are just an indication to try to use the same sort of consistent labeling for any kind of experiment. I will note that you can use the duplicate button to copy this compartment. In this case, I can call this one C2, for example, and maybe I can reuse all of this and change a single value, like let's say it's 3.7 for this pH now. And so maybe in that case, if there is a single change in these, maybe I can call this one pH 6 and this one pH 3. Again, the names are just labels that are not analyzed for anything. They're just labels for you and potentially for visitors to be able to have a shorthand for what this environment represents. Now, in this case, we could have an experiment that has a 6.7 pH and an experiment that has a 3.7 pH feed, and we would choose a different compartment to describe these different environments, with all other things being the same. As we'll see a bit later in step 5, this also allows us to describe perturbations. A perturbation is also described by compartments. For example, here in this study 5, we can see that this experiment A6 starts with a single compartment labeled pH 6.4, and there's a number of information here, a number of data here about the properties of this compartment, the environment, and we'll see that there's a list of perturbations. From a particular time point to a different time point, the pH of the feed was changed. We'll see more about how this is described in step 5, but in you can see also that the compartment was changed from this one to this one, and the difference between these compartments is that the initial pH has been changed. That's all there is to it, and that's a way to describe it, to describe this kind of change in a way that is demonstrable to other people visiting the study. For now, I'm going to remove this compartment. I'm just going to call this one C1, and I am going to move on to adding a community. I'm going to click on the Add Community button, and I'm going to click on the strains input and see that these 3 strains are the strains that I entered in step 2. I can pick, for example, Bacteroides and call this community BT. I could add another community and call it RI for Orzeburia. We can also use a duplicate button here, although in many cases you would probably not have that much to duplicate. There are only 2 fields here, but I can call this one BT plus RI, for example, and add Bacteroides and Orzeburia together. So we have 2 monocultures and a co-culture. Basically, we want to just define all of the communities of strains that we examine in the experiments. In the future, we may have shorthands to maybe pre-fill these communities with combinations of monocultures and co-cultures. But for now, we would like you to take your time and describe your communities, pick labels for them, because you will use those labels in the next step. I'm now going to click on the next button, and the form will move on to step 5, experimental design, where we're going to put together everything we've defined so far to describe our experiments.